Today we're going to continue discussing whether non-human animals can learn language, but we're going to shift focus. We've been talking about language production, and we're going to see that there's reasons for why we should really be focusing on language comprehension. And I'm going to discuss some research on kanzi, a bonobo, which is a species of chimpanzee, and so some studies that try to show that you can understand syntax. And I'm also going to discuss some of the limitations of that work. And I'm also going to discuss some research on dolphins who have been trained with language that has syntax. Alright, so last time we started discussing whether animals could learn a human-like language. And we saw that many of these attempts involved teaching them sign language, and that although they had the ability to produce individual signs and to combine them, their productions didn't seem to display much syntactic regularity. They were kind of jumbled together with no real awareness of the importance, for example, of putting signs in a specific order. So this led researchers like Terrace and his colleagues to conclude that animals can't learn language. Right? Despite the thousands of hours and years of effort into trying to teach chimpanzees how to produce a sentence, the effort has been a failure. Right? So they claim that humans are unique in their ability to learn the syntactic aspects of language. Right? So we have an instinct to learn syntax, just like birds have an instinct to learn to fly. But not everyone agrees with this claim, and in particular, Sue Savage-Rumbaugh and her husband have argued that these conclusions, that animals cannot learn syntax, come from examining language production and not from studying what animals can actually understand. Right? She argues that if animals can display evidence of an understanding of an awareness of syntax, that it's most likely to be found in their ability to comprehend language. Right? Comprehension is generally easier than production, so we're setting the bar too high. If we're expecting production, we should rather be looking at what they can understand. And this is due to the way that language is learned. Right? Children learn language through comprehension. Right? They learn to understand language first, and only later do they learn to produce it. So, in other words, an animal's productions may not reveal their true syntactic understanding. So we know with humans, for example, parents teach language by talking to them about everything that's going on around them, right? We talk to children about what just happened, about what's about to happen. We also talk to children about the various routines that they're going through each day. Right? We point out important objects and verbs and so on. So comprehension is the basis for language, right? For language acquisition. Moreover, another reason for why we should focus on comprehension as the most basic aspect of language is because even if an adult can't talk, right? If they become aphasic, for example, or lose the ability to speak otherwise, we don't say that they're without language as long as they have the ability to understand, right? The ability to comprehend. So again, these arguments serve to show that what we really should be studying is whether animals can understand syntax. In this regard, Sue Savage-Rumbaugh spent her career studying language comprehension as well as production in a bonobo chimpanzee named Kanzi. And Kanzi was raised in captivity with an adoptive mother named Matata. And Matata, the mother, was the original subject of the language study. And Sue tried to teach Matata to use a set of symbols that she called lexicograms. Right, so each lexigram represents a word, but like human language, that relationship is arbitrary, right? The symbols don't resemble the objects referred to by the words. So for example, the apple symbol doesn't look like an apple. So the lexigram panel has about 450 different lexicograms. There's also a grammar, so that symbols can be touched in a certain order. So for example, if what you want to express is that John slapped Pam Banisha, the symbols have to be pressed in that order for it to be correct. Now also this lexigram panel was hooked up to a computer, and in more recent cases onto a laptop, and when Kanzi would press a lexigram, it would read out so that the entire vocalization could be read out as a chimpanzee is giving it. So if he touched the symbols for John slapped and Pam Banisha, the computer would read out John slapped Pam Banisha. Now, Matata was, like I said, was the original subject of this project, but she never learned how to use the lexigram boards very well. But that's not the case with Kanzi. Okay, so here's what the lexigram board looks like, or at least one version of it. You can see there's lots of symbols, all arbitrarily related for the most part to what they refer to. So Kanzi started learning on his own by watching others try to teach his adoptive mother. And because he showed a proclivity towards the lexicograms, he became the subject of the investigation instead of Matata. And you can watch a nice clip of Kanzi interacting with Lisa Ling. This is a segment that she did for the Oprah show. So you can copy and paste it and check it out. It's interesting. It shows some of the communications that use the lexicograms. So, as I said, he started on his own to use the lexicograms, and because he displayed an interest in it, he then became the subject of instruction. And his instruction was very natural, right? People spoke to him as if he understood them, just like you would with a baby, right? You just talk to it, assuming that the baby understands you. And they also pointed to any words that corresponded to one of the lexicograms on his keyboard, so that he could start to make the association between the word, the object, and the lexigram. Right, so he was also able to speak to others because, as I said, the lexicograms were connected to a computer that could read out the symbols as he pressed them. And by the time he was 5.5 years old, his vocabulary increased to 149 symbols. So by that age, he also seemed to be capable of understanding human speech, right? Not just single words, but actual sentences. And this was tested in a study by Savage-Rumbaugh, Murphy, and other colleagues. So what they did was they compared Kanzi's ability to understand sentences with that of a 2.5-year-old girl named Aliyah. And Aliyah had also been trained with the lexicograms in a way similar to Kanzi, and this is because her mom worked at the research center with Kanzi. So they trained them both at the same time. So Kanzi and the girl, in separate sessions, were given 415 sentences, and the sentences tested their comprehension by requiring them to carry out certain actions. Right? They had to fulfill certain requests with various objects located in the lab. So there was a person who announced the sentences, and this person sat behind a one-way mirror so that they could not cue the child or Kanzi. And the sentences were presented via headphones to Kanzi and Aliyah, and the attendants that were in the room with them couldn't hear the sentences, so they also couldn't cue them how to respond. So here's some sample sentence types. For example, asking object X to be placed in or on a transportable or non-transportable object Y. So for example, put the milk in the water. Or do action A on object X with object Y. Right. So for example, stab the ball with the stick. And another type would be pretend that animal A did action B on recipient Y. So for example, can you make the bug bite the doggy? So they use 7 different types of sentences with multiple sentences of each type. And they looked at whether they carried out the right action for each sentence. And they both did remarkably well, right? Kanzi actually doing a little better. She got 74% of the sentences correct, right? She carried out the appropriate action. And Aliyah got 66% correct. So according to Savage-Rumbaugh, this shows that Kanzi is able to understand language, right, including syntax, at a level of about a 2.5-year-old child. But I also want to point out that not everyone is convinced by the results of this study and what it claims to show. Right? And one of the skeptics is Wynne. And according to Wynne, the problem with it is that in very few cases was it actually ambiguous as to what could be done to what. Right? So to figure out what to do, Kanzi would not have needed to understand syntax. Kanzi just needed some common sense. Right? So Kanzi would just have to understand some of the words and then use common sense to figure out what to do. So the sentence, stab the ball with the stick, is not really ambiguous. Right? The stick can stab the ball, but not really the other way around. Right? So if he understands stab, stick, and ball, he doesn't have to understand any syntactic relation, like which is the object and which is the subject and the predicate and all that stuff. He just has to know what the words mean and use common sense to figure out what to do. And the same is the case with some other sentences, right? Although he also responded correctly to the sentences, grab Janine and give the trash to Janine, right? And there is syntactic information here, right? In the first, Janine is the object of the sentence, right? The thing being grabbed. And in the second, she's the subject, right? The person to whom the trash is to be given. But again, Kanzi doesn't need to be aware of these syntactic facts. Doesn't have to appreciate it in order to carry out the right action. Right? In the first sentence, right, the verb grab doesn't really allow for any other interpretation than to grab the thing that is named. And in the second, there's only really one plausible interpretation, right? Kanzi could give the trash to Janine, but he couldn't give Janine to the trash. So again, you don't need understanding of syntax, you just need common sense. So, what Wynne says is that rather than using an understanding of syntax, Kanzi could just have used common sense regarding how objects can interact with each other. So, while Kanzi and other apes seem to be able to use words, and maybe even to combine them to create novel meanings, there is very little good evidence, right, that conclusively settles the issue, that they're able to understand and produce the syntactic aspects of language. So for Wynne, he would say that those, when you look at their production, right, it makes sense that they're not really paying attention to syntax, to the order of the symbols, and we also have no evidence that they're doing that in terms of comprehension. Right, so we have very little evidence that any non-human animal can crack the syntactic code and to understand really complex rules of syntax. So what's the difference? What's the difference between humans and other primates? And I talked a little bit about this in the first part of the lecture, lecture 15, part 1. According to Chomsky, the famous linguist, the difference between humans and animals, and other animals, I should say, has to do with the fact that human children are born with a highly specialized language acquisition device, the LAD. And this LAD has built-in knowledge that allows children to learn syntax. Right? It has very general rules of language that develop naturally, and children use this understanding of language in order to figure out what the syntactic rules are of whatever specific language is spoken around them. Right? So it's knowledge of the structure of language, it's a general template for language, and they use it to guide their learning of whatever specific language is spoken around them. Although it's innate, it's not immediately evident. Its operation kicks in around 2.5 years of age, and that's before that, right? Before 2.5 years of age, children will produce single words, or they'll produce pairs of words, but they won't produce a sentence, and there'll be very little syntactic regularity. All of a sudden, the child hits 2.5 years of age, and they start producing sentences, right? And they start to learn rules of grammar. That's because the LAD has kicked in. Okay, so before 2.5 years, children combine symbols with very little syntactic regularity, and it's usually just pairs of symbols. Right, so this language acquisition device is specialized. All it does is allow children to learn the rules of language. It's independent of general intelligence. Right? And what does that mean? It means that it doesn't depend on a child having a certain amount of intelligence. Right? Defective intelligence doesn't mean that a child will not be able to learn grammar. And this mechanism also seems to have a critical period, right? And that's puberty, right? Once a child hits puberty, that special ability to learn grammar starts to deteriorate, right? The module seems to stop working as efficiently. Anyone who's tried to learn a second language after puberty knows that's the case, right? I think of my own father. He started off speaking Spanish, then we moved to Canada. He spoke English. There's lots of rules of syntax that he has not mastered and probably never will. I, on the other hand, I also my first language is Spanish, but I learned English before puberty, so for the most part I have mastered the rules of syntax. Right? Critical period. Alright, so what kanzi and other animals are missing is this specialized mechanism, right? This module for acquiring syntax. Right, so their ability to answer questions and to respond appropriately to statements reveals their intelligence, their ability to solve problems, but not their ability to decode syntax. Right, so they use their common sense to figure out what to do given what words they understand and what the current situation is. Right? So the consensus seems to be that animals can't do syntax for the same reason that humans can't spin webs or navigate by seeing magnetic waves. Right? They simply don't have the right mechanism for doing it. Okay? They lack the specialized mechanisms for doing so. But we have to be careful because there is some evidence that at least some animals can be taught at least some rudimentary syntactic rules. So I want to end the course by discussing some of the pioneering research of Lewis Herman. So he's examined the ability of bottlenose dolphins to learn signs and to understand simple sentences using those signs. Right, so he invented a very simple language with simple syntactic rules, all based on hand and arm signals. So this work began in the 1970s in Hawaii. The research, like Sue Savage-Rumbaugh, emphasized comprehension, but it did so from the very start. And I'd like to point out that he's not talking about dolphins producing language in any way, only being able to understand it. And the researchers worked predominantly with a dolphin named Akia Kamai. So as I said, they constructed a sign language in which individual words, were represented by gestures of a person's arms and hands. So you can see some sample signs here. the hands move in a certain direction, in a certain position to indicate different things like a pipe, a surfboard, the water, or a frisbee. And the person wears dark glasses so that they can't cue a Chiappe with their eyes as to what to do. So they were also taught location words such as left and right, which are interpreted relative to the dolphin's location. So left means to the left of the dolphin and right means to the right of the dolphin. So they could be used to refer to objects, to different objects that have the same name. So like left hoop versus right hoop. So if there's two hoops in the water, left hoop would be the one that's to the left of the dolphin and right hoop would be the one that's on the right. And as I said, there's syntactic rules, and these rules were very simple, and they're only based on word order. And they govern how sequences of words could be arranged into sentences. The vocabulary, again, very simple, 40 words, together with word order rules. But combining these things, they allow for thousands of unique sentences. So when they're testing the dolphin, right, they tested, so they trained them with certain sentences, but then they tested his comprehension using novel sentences, right? Why? Because we want to make sure that he hasn't simply learned how to respond to a particular sequence of signs in order to get a reward, right? As we've said with every other area of this course, you need to show, if you want to demonstrate understanding, you have to show that whatever they've learned transfers to different stimuli. So the simplest sentences were instructions to do specific actions on specific objects. So for example, a sequence of two gestures, surfboard over, directs the dolphin to leap over the surfboard. And the sequence of the gestures left frisbee tail touch directs the dolphin to touch the frisbee on her left with her tail. And others require the dolphin to construct a relationship between two objects, such as taking one object to another object. And importantly, to interpret these sentences correctly, the dolphin had to take into account both the word meaning and the word order. So for example, the three gestures, person, surfboard, fetch, tells the dolphin to bring the surfboard to the person who's in the water. But flipping it, right, surfboard, person, fetch, requires that the person be carried to the surfboard. So these sentences, there's different orders, and the interpretation that's given really matters. So unlike the studies with kanji, the sentences were ambiguous, and the only way to get the reward was by paying attention to the word order. And the dolphin was proficient at interpreting these various types of sentences correctly and generalized to novel stimuli. So what Herman concluded is that the results show an animal's ability to process both semantic and syntactic information, right, in interpreting these language-like instructions. Right, but we need to put this into perspective, right? First of all, the syntax they learned is very primitive compared to the syntax underlying human language. Right? The rules of syntax that underlie human language are vastly more complex. Moreover, they needed a lot of explicit instruction and reinforcement in order to get the dolphin to learn this simple syntax. Right? Another way of saying that is that it doesn't come naturally to them. And this syntax is not part of their own communication system. Right? Their own communication system, as far as we know, it doesn't have a syntactic structure. It doesn't have a system of rules for combining symbols to create novel expressions. Right? So this is very different from the human case. Right? Human children pick up rules of syntax with relative ease and often without any explicit instruction. Right? Children learn this on their own. Right? They test hypotheses that they formulate on their own about how language works, And even if you try to correct a child, she will ignore you because she's trying to work out the rules of language all on her own. Alright, so to conclude the course, right, our species seems to have taken a unique path in terms of the ability to learn rules regarding the relations between symbols. Right, a quantum leap over what other non-human animals can achieve. Right, so this ability to understand grammar and syntax naturally and without a lot of instruction, right, that's part of our unique human heritage. And language is very, very important, right, because it's yielded probably the most powerful, the most versatile communication system in the biological world, right, and it's facilitated considerable cultural achievements. Right? Without a system of communication like language, right, you can't produce future, you can't imagine the future, and you can't talk about the past. Right? Language provides a representational system that allows us to do that, to expand the time horizon, right, that we can communicate about. And there's nothing else like it. And once you pair that with writing, right, putting stuff down on paper, that just amplifies tremendously our ability to think, right? Because things like science and philosophy and literature and religion, none of these things would be possible to the extent to which they are carried out today without language and without language being written down. Anyway, I hope that you've enjoyed the course.